morning, depending on your time zone. Thanks for joining us today. My name is Mike Carey. I'm the Chief Strategy Officer and co-founder of Atlas Space Operations in the United States. And Atlas is a service provider for ground systems. And one of the things that we get to do in a very excited way is engage with men and women across the world who are involved in Earth observation. And today's panel is going to be talking about real-time Earth observation. And I'd like to focus on not just where we are today, but in context of yesterday, what the future portends. And we're very fortunate to be hosted and supported by Clepsydra Technologies. And Pablo Giglino is the CEO and founder of that company, and also a panelist today. He's the founder of CEO Clepsydra Technologies and has over 20 years experience in the finance industry. One of the neat things about Clepsydra is bringing financial technology, fintech, to the aerospace industry and managing to move data faster with lower energy and lower heat expenditures to actually address some of the issues of real-time imagery in process. Parallel to his work in finance, Pablo successfully studied and received a PhD from Surrey Space Center in aerospace engineering, where he got involved in several aerospace projects and seized the opportunity by creating Clepsydra to respond to the needs of cutting-edge computing by implementing successful software techniques from fintech for the space and onboard systems. With us also today is Frederick Brun. Dr. Frederick Brun served in a variety of leadership and entrepreneurial research roles during his past 20 years. He's currently the director and CEO of Unibop AB. He's previously co-founder of the satellite company OSA Microtech, which I was fortunate to be the North American CEO for a short period of time, and now AAC Microtech Clyde Space, where he led the mobile surveillance robot company. Separately, he led the mobile surveillance robot company Rotundus AB. Frederick serves as an adjunct professor in robotics and avionics at Marla University since 2013. He's also chosen to be an Eisenhower Fellow and to meet leaders around the U.S. Regarding AI, robotics, and automation. We're also joined by Dan Garrissey, who's the president of Voyager Space Services, VSS, a subsidiary of Voyager Space. Prior to joining Voyager, Dan spent several decades in international asset management and wealth management industries. As a founder and CEO, he's led several successful startups and has run multi-billion-dollar P&Ls for global financial institutions. For the past 16 years, Dan's been the chairman of the board of the Planetary Society, the world's largest space interest nonprofit founded by the late astronomer Carl Sagan and JPL head Bruce Murray. Also with us today is Barbara Plant, who's the chief architect at Orbifab, a logistics company focusing on building an in-space propellant supply chain for LEO, GEO, and cislunar space. Barbara has served as the director at Planet Labs, overseeing the configuration and launch of 6 SkySat spacecraft, which provide high-quality EO images and video from LEO. She spent decades involved in the concept, design, deployment, and operation of spacecraft, including Iconos 1 and 2, the world's first commercial remote sensing system. She's an active contributor to the Consortium for Execution of Rendezvous and Servicing Operations, or CONFERS. I'll add she's also an active member in the Planetary Society. And last but certainly not least, Pierre-Philippe Mathieu is heading the Philab Explore office at the European Space Agency and in ISRIN, aiming to connect people, ideas, and digital technologies to help shape the future of Earth observation. He spent 20 plus years working in the field of environmental and ocean modeling, weather risk management, and remote sensing. He has a degree in mechanical engineering from University of Liège and a PhD in oceanography from the University of Louvain and management degree from the University of Reading Business School. Welcome to each of our panelists. Thank you for joining us today, and I'm honored to be your moderator. So if I may, since I've given you a brief introduction, what I'd like you to do now is take a moment or two to give us a little bit about, you get 3 minutes roughly, to introduce yourself more in depth and tell us a little bit about your activities and or company, if that's all right. So if I may, I'd like to start with Dr. Pierre-Philippe Mathieu.
Okay, thank you very much, Mike. Can I just check you can hear me?
Loud and clear.
Okay, perfect. So I'm really honored to be here and to make new friends. It's always good and to be inspired with you guys, and also to share my passion for space, and in particular to bring new digital technologies for and in space. So I have the privilege to lead a team of researchers at ESA in Esrin near Rome, in Frascati, where you are warmly invited. And these researchers are exploring the strengths and weaknesses of new technologies, in particular digital technologies, such as artificial intelligence, blockchain, and quantum computing, to name a few, with a particular focus also on edge computing, and we will talk a lot about it today. And what we try to do there is really to connect people with ideas, and in particular to reach out to domain outside space, because there is a lot of startups out there that do not know that we have all this open data on the state of the planet, and they get very excited when they discover this, because they can really make an impact if they implement their technology to our data set. So this is why I'm really keen to do events like this, so that we can reach out to new community. And as part of this work, we also build connection with industry. So we have programs that can help industry growing, testing new service, building new business models, etc. I'll post a link later where you can check out these programs. So the European Space Agency is there to provide you with tools, capability, so that you can build the new generation of services, you can build cool technology for space, and you can also build business. So we want people to make business with our data. We want people to make science with our data. And I'm just come back from a huge event called the Living Planet Symposium, which was one of the first physical events since years. And it was amazing, the energy and the ideas that were shared there, because we are human beings, we need to meet to exchange this. And I can tell you, I was really, how can I say this, overwhelmed by the quantity of science, the new ideas, the application of AI to space. It's really booming. It's a full renaissance, and also very cool mission concepts. We just released a call for new ideas for future Earth Explorer. I've posted this link on LinkedIn, so please reach out if you have ideas for cool missions. Now is the time. Thank you.
Thank you, Pierre-Philippe. Barbara, let's shift over to California.
Yes, good morning again. My name is Barbara Plants, and I am the chief architect at Orbit Fab, a company that has a mission to enable a really bustling space economy by providing in-space propellant. And as we know, the old paradigm of space was that we would build spacecraft and basically they were single purpose, short lifetime adventures. But now we're finding that there's a tipping point, and we're seeing a lot of interest in providing various kinds of propellant to spacecraft in LEO, GEO, and even cislunar space at this point to enable life extension activities for spacecraft and basically enable a more kind of in-space bustling economy. I'm all about infrastructure. As Mike said during my intro, I'm one of the people that over the years I was involved in the creation of all these single-purpose spacecraft, which many of them lasted for quite a while, but then they died on orbit, and then that's it. We are now contributing to space debris. those spacecraft are no longer usable. So I feel that at this point in my career, it's up to me to see and to envision where things are going with a vibrant space infrastructure to be built up that enables a slow progression, LEO, GEO, and away from this planet that is enabled by an infrastructure that can support the missions that we envision for the future. And yes, I am a member of the Planetary Society, but I also am a member of the LightSail 1 and 2 launch teams. And I'm totally thrilled, especially about LightSail 2, that we demonstrated flight by light. How's that for a plug, Dan, for the Planetary Society? Truly an exciting, just a truly exciting mission. So my passion and my goal is to take life experience and prior experience with spacecraft as they were built, and to envision and enable a kind of a new generation that has longevity in mind, and really promotes exploration in a new and different way.
Great.
Thank you.
Thanks, Barbara. And so, Dan, I'm assuming, are you in Texas, Dan?
Yeah, I'm in Houston.
Okay, so we've gone Italy, California. We're going to work our way back around. We're going to go to Dan in Houston, please, if you don't mind. A couple of minutes on yourself and your current activities.
Sure. Thanks, Mike. And hi, everybody. I'm Dan Gerasi. I'm president of Voyager Space Services, which is a subsidiary of Voyager Space. I'll echo, Barbara's comment about, infrastructure being a really critical component. I think that the term is getting used a lot, but for good reason. Voyager Space right now is in the midst of the process of starting to build Starlab, a commercial station, while at the same time looking at other capabilities like mission extension kits and some of the other activities the company's involved with. But Voyager Space Services, VSS, was created to help the new space economy, specifically all of those young and emerging companies who have brilliant technology, but don't really understand how to set up and operate a business. And when you look at one of the biggest challenges for the customers out there, whether they're government, military, or private, companies with great technology sometimes can't get a contract because there's no company there. They're not sustainable. They're not well capitalized. They don't have the operating infrastructure. So what VSS does is we connect them to 20 plus categories of services to allow them to outsource everything they'll need to operate the company so that they can focus their time and energy on their technology. Also something their investors want them to do. And I come to this conversation today with a perspective that's based on the hundreds of new companies and founders that I interact with all the time, and a very long background in the area of investment, where looking at these companies as investor friendly and viable investments is a critical component of accelerating this new space economy. We can't afford to have a high fail rate, which has been the case, including for companies that are in the cyber world. The technology is not getting across the finish line. So I'll come at it from the perspective of what's needed, but also what we're seeing in terms of these emerging companies. And it's a very exciting and encouraging view of what we're seeing.
That's great, Dan. That's a great position. I'm really excited to see, the variety of views that we're going to get on this panel. It's really great. So we're walking our way back. I'm going to go to Frederick. I'm assuming you're in Sweden today.
That is correct, sir. And thank you very much, Pablo, for the invitation. It's a great pleasure to be with you guys today. Fredrik Brun, I'm one of the co-founders of Unibap. I'm also the chief evangelist in digital transformation. What it means is that I'm working on our space and terrestrial cloud solutions. And what's interesting is that we are marketing something under the name Space Cloud. I'm very happy to say that Pierre-Philippe Machaut, who is also on the call today, has been a sponsor of this through the InCubed ESA program, where we actually developed the framework that makes up Space Cloud, that allows us to orchestrate different loads in space. And what's interesting is that we set out to democratize space 9 years ago in 2013. We wanted to establish the same kind of infrastructure in space that you have on ground. So the same kind of computers, same kind of software usability, so that you can basically take a terrestrial app and deploy it in orbit. And now we were able, with the support of ESA, to do all this last year. So the first complete Space Cloud solution was launched in June last year. We have so far been able to demonstrate more than 140, 150 now applications running in space, utilizing CPUs, GPUs, neural network accelerators, FPGAs, and local storage, etc. And they're all containerized in the same manner that you do on ground. So you package your container-based application, upload it to the spacecraft, and you orchestrate it. So we have now, together with ESA, actually just a week ago at the 4S Symposium in Portugal, published how we are able to port very advanced algorithms in a matter of hours to days, upload them into orbit and run them in orbit as well, so that you can significantly increase the utilization of your space assets. So we have space computers now that are packaged like a terrestrial server that can be very quickly deployed and launched into space as well. And the beauty of this is that, at least in a Swedish context, we go from maybe having 250, 300 dedicated space software developers to having tens of thousands of developers. Because if you have the slightest knowledge about TensorFlow or OpenCV or the robotic operating system or whatever piece of software that you are used to use on ground, you can now use that entire infrastructure in space. And this was particularly highlighted with ESA last year when we flew an entire L3 Harris geospatial ENVI IDL software suite in space, so that if you have any terrestrial application that uses ENVI or IDL backend, you can immediately deploy that into orbit and reuse that entire software infrastructure. And we spent a whopping 28 hours getting that into orbit as an example. So what we do is that we build space infrastructure, both hardware and software, but it's an open ecosystem so that anyone can leverage it.
Well, thank you for your setting the stage. There's a trend here. I'm hearing a lot about what it takes to get real-time data down, and we're not talking a whole lot about sensors yet. And I'm looking forward to the dialogue that we have, because I think what we're building a case for is it takes a lot more than just a great sensor to turn sensor data into real time. So with that, we're going to land in Switzerland with Pablo, and founder of Clepsydra, also the sponsor of today's forum. And so Pablo, some opening remarks from you, sir.
Oh, hello, everyone. Thanks, the panelists. I am quite honored to be surrounded by such a impressive background people. Yeah, like Mike said, I am the founder of Clepsydra. I invented the concept of Clepsydra. The idea of using technologies coming from the trading industry into such a small computer of the ones that goes on board satellites, it was quite challenging at the beginning to do, but it's paying off. We're seeing excellent results in performance. In that sense, I have to thank Fredrik and his CTO, Oscar, in particular, because he has been really challenging us and giving us very complicated algorithms to optimize that we keep managing to do. We are focusing a lot on Earth observation at the moment. We have done some project with some department in ESA, in the software area, but working very heavily on Earth observation algorithms. We have been running them with our software. We managed to increase the performance a lot, because our goal as a company in the area of Earth observation is real-time Earth observation, like the name of the panel. No? So we want to be able to produce a software on board that will be able to make decisions and enable the possibility of reacting real time to events happening in Earth detected by satellites, which at the moment seems to be quite challenging, but this is our main goal. And yeah, this is why we're here today to discuss. Thank you, Mike.
Thanks, Pablo. When I was thinking about Earth observation and the real time, the title is real time. It took me back. I spent the majority of my life in the United States Air Force, and my boss used to work on a C-130 satellite recovery team of capsules that would be deorbited from spacecraft, and that's how we used to get imagery from space back in the olden days, which was quite a feat, right? To fly a plane out from Hawaii and with big whiskers, go capture a parachuted capsule of film and fly it back to the base in Hawaii and process it like a Kodak film processing and report whatever strategic information you've learned from, however long ago the image was taken. And that was like cutting edge. That was, rocket science, if you will. And so, and then we came into this era of I can actually, transmit the data down and process it and get it in near real time. And near real time, of course, took on all kinds of different, what does that mean, right? And what is latency to you versus latency to a weather person, and all kinds of different constructs of time when we think about imagery from space. So real time imagery from space, I guess I'd like to go around the panel and just let's kind of put some bookends up there. When you think real time Earth observation, what does real time to you mean? Dan?
Well, other than the kind of the obvious definitions, I think it's the real big picture is about speed in so many different ways. And I think as we've seen terrestrially with technology, once someone demonstrates that something can be done at a much higher speed, shorten the time to getting that data and be able to act on it, I think that starts to become the desired norm. And it's clearly a trend that's moving pretty aggressively. So for me, depending on the user, depending on what the situation is, I need to have this information now. People need to solve the delay in getting it to me as the consumer of that information. And we're past, I think, that threshold of where people say, it's possible. So step it up. And it's a competitive issue as much as it is a commercial one.
Pierre-Philippe, what are your thoughts on that?
Yeah, I think that Dan is totally right there. I've seen in time the change of expectation. I remember a decade ago, people didn't care too much or had very, let's say, flexible definition of real time. It was also called near real time, if you remember.
Right.
We have a very complex system of getting the data down, which even today takes a few hours. But the expectation of people, in particular the new generation, my kids, is instantaneous information. I mean, if there is a Wi-Fi during the COVID crisis that had no connection, this was a disaster. They need to be connected all the time and have things at the snap of their finger. So I think the expectation that is there, it will drive the technology. I think technology can solve this. Frederick is showing how AI can actually extract the information. So even if we are slow in downloading the full data, because we talk about big data here, we have terabytes, so it's It cannot be instantaneous still today, but we can get maybe the information on which we can react, so the whole system can become reactive. Because if we can put the brain closer to the eye as we have in our head, we can react much faster. Now the brain is very far away from the eye, so we are getting there.
I like that, and I like that analogy of the brain closer to the eye. I'm gonna take a note. I'll probably use it if I do. I'll cite my source.
Okay, good.
Frederick, what are your thoughts on real time?
I think that a lot has been said, but I read that there is a big European Union project that actually specifies real time from space being within 3 minutes. So I'm starting to see more and more references to 3 minutes being sort of a real time measurement when it comes to space. I can give you a reference point that we demonstrated in space last year, and this was again together with ESA. And the challenge was to analyze 80 megapixels, so a full frame WorldView 3 image in orbit, find aircraft flying on the ground, identify them, geolocate them, and send a list, including small pictures of the aircraft, down to ground within 3 minutes. And these experiments were executed in space with preloaded data from WorldView 3. And we were able to demonstrate with the capabilities that we already deployed in orbit, we are able to analyze 100 square kilometers, identify moving aircraft, airborne aircraft, geolocate them, send down a list of coordinates and a picture of every identified aircraft within 1 minute to a handheld terminal. We do the analysis in orbit with an unoptimized algorithm in 43 seconds for 100 square kilometers. So there is a tremendous amount of capabilities that can now be deployed. And as you already mentioned before, we can start to prioritize, we can reason in the data. So even if you have terabytes to download, you can prioritize which data will come down first, what kind of indications would you like to either send down to ground or send to other nodes in the network, so that you can start to do data fusioning in orbit. You can do autonomous operations and things like that, which has a great potential impact on the ground infrastructure for communication as well, because you can optimize those links. We had another experiment that we published with ESA last week at the 4S conference about autonomous flooding detection from orbit using Sentinel-2 data in that case. And we demonstrated in orbit last year that we can reduce 2.5 gigabytes to 300 kilobytes and send that down to ground within minutes as well, and say that here is a potential flooding, you should look into this as well. So we were at the crossroads where you can start to talk about real time being within 1 to 3 minutes for data products being generated in orbit.
Well, so that's, you've kind of crossed into an interesting part of this real-time discussion, Frederick, is and I'll hand off to Barbara here, is like real-time imagery of Earth up from space, or real-time imagery in space of space still drives a significant latency issue, right? I mean, things that are happening with Orbit Fab, right, require, you're talking about infrastructure in space to facilitate all kinds of different missions. And
Right.
so, Barbara, can you talk a little bit from your perspective on what real-time means and all the different facets?
Yeah, I sure can. A big challenge to me now, as we architect our on-orbit missions to demonstrate refueling, is that we are wrestling with where does the edge exist, as we're having ground stations in the loop that are working to command proximity operations and the last, let's say, centimeters of distance between two objects that will be trying to connect and dock. Where does the ability for ground stations to support us stop, and where does the requirement to either connect interact RF-wise between spacecraft or have some other methods of light communication, even LEDs happening at the last few seconds before the docking occurs. I think of real time in different ways. Obviously, I'm splitting this up into a ConOps that requires different solutions at different gates in the mission. As a software engineer for many years, I also think of real time as not 3 minutes. That's too long for something that's like a medical application or something. That's just so it has to do with the customers. Me as a customer for communications is levying constraints that are actually tighter than 3 minutes. But we're not talking about EO data products. We're talking about an infrastructure play where I need to invoke whatever solutions work best to get a continuous communication path, no matter what that looks like. Even,
Right.
signal
No.
flags.
I understand.
Yeah.
Thanks, Barbara. And Pablo, I know you deal with, so Barbara's really touched on something we've kind of talked around is, it's latency, 3 minutes means the product. I mean, obviously, milliseconds is another form of timing standards. And I know, Pablo, you work in the very minute parts of processing to make things remarkably faster in million microseconds. And so what are your thoughts on real-time Earth observation, what real time, and how do you bound that in your construct?
Yeah, that's a good point. I was thinking when you mentioned this that everyone has a different definition of real time, no? For some space companies, maybe hours will be enough, and this is for them low latency or real time. For others, it's not like that. For a banker, it's always less than a fraction of a millisecond. So it varies from one person to the other. Yes, for us, real time, we always navigate in the area of milliseconds and microseconds in Clepsydra. That's true, from the inherited background of the software. And in order to achieve some kind of real time in the Earth observation, I think I am quite in agreement with what Frederick was saying, and also Pierre-Philippe. The key thing is to have the brain close to the camera, no? And this requires intelligence. So in order to achieve real time Earth observation, the intelligence has to be in the onboard. It has to be on board in order to achieve that. And I think we're all kind of aligned towards working in this direction, especially in Clepsydra. This is our kind of main goal from the software we developed.
So, first of all, what I'd like to announce to our audience, and thank you, audience, for joining. I see there's quite a number of participants in today's webinar, and to become a participant, I encourage you to type in your questions, if you will, or at least be prepared to. I'm assuming, Pablo, that they can voice in. Is that true?
I think they can type questions.
Okay, type your questions. Think about questions you'd like to ask of our panelists. They come from a variety of segments, which represent, quite honestly, not just their current roles, but their decades of personal and professional experience. Quite a wealth of knowledge. And so feel free to ask questions regarding anything from what's the investment landscape look like? What are the future skill sets for tomorrow's companies and industry going to need? Or what are their personal experiences and successes and failures? I mean, I think there's just a lot to learn from this panel. So feel free to type those into the meeting chat, and then I'll be glad to entertain and moderate those questions and field them as well, which means in a nice way, I'm going to read your questions to the panelists and give them a chance to think about it. One of the things that I didn't hear anybody speak of is streaming, real-time live streaming from space. And when I think of real time, I think of relative, relevant, and contextual, right? Not everybody needs a video from space to do their job, to get their data. Some people think it's more eye candy. It's something to look at. It's not really something you can analyze. You don't get the data down to crunch. But I would argue that depending on your mission, depending on the customer or the consumer's task, that really defines what is a relevant real-time frame for them. I mean, weather data is so perishable, right? After a certain period of time, it's great for analysis and it's lousy for warning people, right? You get to build models, but you don't get to say, here comes the storm in 5 minutes. Fleeting military targets are relevant for a short period of time. But understanding Earth's climate, Earth change, environmental change, that takes far more than you don't necessarily need real time for all of that. So when you're thinking about a customer base, how do you, I know from a ground perspective, if I get context of data latency misunderstood, we go around the block a couple of times discussing, well, what did you mean when you said? So you try to build that structure for conversation early in understanding the client's requirements. So how do you, as a client, how would you best articulate your requirements to somebody who's either building a sensor, building a satellite, developing the infrastructure with the backhaul, or the battery platform for charging such a device that needs to be able to be responsive? How do you go about articulating the requirements to your customers? Barbara, I'm going to start with you.
That's really great. It brings to mind that one of the engineers, the computer vision engineer on staff, is wanting real-time video as we try to close distance between two spacecraft. And knowing that there are latency issues, of course, involved. It's not like we can actively command based on that video, but it has certain commercial relevance to us as a company. Yeah, but so Mike, if I'm coming to you and I'm asking for support, let's say from Atlas, I'm trying to quantify my expectations, not that I'm really expecting to run the mission based on that video, but developing some kind of stakeholder, both external and internal stakeholder desirements there so that I can articulate, gee, Mike, it would be really great to see this video within the 3 minutes. That could be enough for our purposes. Ruling out, of course, that knowing that there's latency involved, you're not trying to, actively command and such with that. It really is so. It's terribly, terribly application dependent, and of course, everyone is trying to get the best fidelity they can, but there are certain, just physical limitations on latency from space that are unarguable. So from there, it's do we go direct via conventional channels, and optical is starting to step up as an option too. But are you placed well enough on orbit to take advantage of optical? As usual, space missions and planning are very complicated, X unknowns kind of thing.
Well, let me, Pierre-Philippe, let me ask you, sir. So Barbara broached the optical question, right? So when I came into this industry, which albeit late in life, but everyone said that X-band observers were going to Ka, and Ka is going to go to W, and W is going to go to optical. And there's always this next better way of getting more data down faster, securely. And so what are your thoughts on the spectrum implications of real-time Earth, and is X-band enough? Do we have to go optical, or is there You know, is it kind of like AM and FM radio where there's still a role for AM, it's just somewhat diminished because there's more opportunities in other spectrum, if you'll allow the analogy.
Okay, I'm actually not an expert of this, and I thought I would reply to the previous question, but that's fine.
You can feel free to refer to, okay, respond to the previous question, and then I'll throw the other one out to either Dan, Pablo, or Frederick.
Because they might be related. In fact, when you have a limitation of bandwidth, or whatever the technology you use, you need to become clever to actually make the most of it. And that's the whole discussion that we are having about AI on board. Some people don't think it's AI, they think it's compression. But at the end of the day, the whole thing of science is coding information in smaller formats so that it can be digested. An equation is a condensation of knowledge, if you want. So if we as human beings, we can do that, we will also better use this bandwidth that will be limited somehow. But to come back to your previous question about live data and requirements, I mean, my experience in this has been that it's very difficult to articulate requirements because people do not know exactly what they want. And you have always this game of the egg and chicken. What can you provide? What do you want? And at the end of the day, it's through dialogue with the user and really understanding their problem, what they are doing, that you can squeeze out the requirements. And then they evolve very fast in time. As we have seen, the expectation on latency is totally different today. And we are building mission with previous expectation. And I've seen it with the spatial resolution of things. Once the new space has come in with very high res and daily revisit, everybody wants this. So where are we going? And the question of streaming data is very interesting because the discussion we have for the moment in ESA and other organizations is to build what is called a digital twin of the Earth. So, you know, they are really trendy these days, the digital twin. And we want to do the biggest one of the Earth, maybe even the universe. And the idea is to bring together all the data we have, so not only from satellite, but IoT, open data, but also from models, the one of meteorology/climate, so that you can also predict at very high resolution. And the expectation on this resolution is also increasing. And you have new players like NVIDIA, which enters this space thanks to AI and what they call physics-informed neural network that is approximating the equations. So the debate about streaming is slowly moving to a debate about can we have a live digital twin that would combine together the modeling capability, the different type of data, so that we have the most comprehensive picture of the Earth in time, not only a stream of data, but a synthesis of what's happening, and then the ability to predict very short term, so nowcasting, and medium long term. And just to tell you how the expectation is changing, I was in this Living Planet Symposium last week, an amazing event, and it was raining. And people thought, do I need an umbrella? And what they did is they didn't check the weather forecast. They went on the map of radar data in real time. So they were assessing by themselves what was happening in real time. It was totally new to me, and this is non-traditional, let's say, source of data, but it's to show you how the technology is evolving with digital technology and how this aspect of streaming data would move into an aspect of streaming information, combining all these things together. At least that's what I feel and I notice is happening.
That's a great anecdote, and so I guess I feel younger now because I check my radar before I check my weather forecast because it's so telling me what's coming, and I can figure it out, you know. So anyway, Pablo, comments on the context of this part of the conversation.
Yeah, there were so many topics, I got a little bit lost, but yes.
Well, requirements from customers, and then maybe transition that as a, you know, what does that portend for, you know, either spectrum or constraints of processing in coding and getting data down faster. Still trying to speak to the real-time elements, customer requirements, how do you collect that as Pierre Philippe said, you know, it's through the dialogue and you squeeze the requirements out through conversation and, you know, but at the end of the day, you've got to code it. You've got to create the means of getting it.
Yes, that's right. That's right. Yeah, in that sense, we have seen all variety of things. Because Earth observation is not only, or doesn't only involve necessarily sending data to Earth only, but there is also a component of using the data inside the satellite for their own operation. No? Like it was mentioned, I don't know, I think it was Frederick or Philip. This information can also be used to really point or check if you are really pointing the camera to Earth. So there is a component also of self-control in the system. So there are all type of requirements in this sense. Of course, some of them are to receive the data as soon as possible, as real time as possible. Especially, I think defense sector is particularly interested in this. But like I said, it's also a part. I think ESA. We have seen this within ESA, the interest of using the data to calibrate the solution, the aircraft itself, the spacecraft itself. But the next big thing we are seeing, at least from our perspective, also coming from the ESA side, is using more AI for more things. One area of AI that is becoming more or less common ground is using AI on board to discard non-relevant data. So, for example, if the image you're capturing is full of clouds and you are not able to see the actual terrain, you may discard this image altogether. So this is more or less well established, but there are new things that we have been evaluating internally in Clepsydra. For example, compression using artificial intelligence. So this is something quite new, and you can compress data substantially more using AI, because in AI you don't need to compress pixel by pixel. It's more a matter of features. You can say this is a face, this is hair, this kind of thing. So the compression become substantially more efficient. Maybe it's not lossless, but still can be quite good to assess certain things. So I think that the trend is towards more AI, more intelligent algorithms deployed inside the satellite that will enable either real-time solutions or sending quite relevant data down to Earth. No?
And so, Dan, are you seeing, take what Pablo has just talked about here, and are you seeing different trends in technology being applied to capturing more data real time? I mean, I know Frederick's his endeavor, and I'll come to you next, Frederick, on cloud versus edge, but I mean, what technologies are you seeing being more successful, or maybe what are some risky ones that are being tried out that haven't proven successful yet?
Well, it's interesting because I think, one of the questions you asked earlier about optical and, this whole area of laser comms, it's here. It's being pulled hard by the military. If you take a look at Lockheed's Parsec program, which is a fascinating endeavor. They're actually getting into a business that they're going to stay in themselves and operate, as opposed to just building something for someone. An entire cislunar communications network specifically for assets and people working on the surface of the moon. This notion of speed and using all forms of optical, I think, is driving, and it goes back to this issue of getting toward real time. I think that some of the technologies that we're seeing are you have young companies that have figured out how to miniaturize a laser comm terminal to where you can put them on rooftops everywhere and use them to dramatically change the landscape in terms of the speed of communications, even though they've got some of the challenges environmentally and from a weather standpoint. And so We see that. We see things for Earth observation that are using different technology to do ground penetrating observation, to where they can, there's a young company out there now that can pretty much see about 1.5 kilometers below the surface from orbit, for, you know, everything from resources to archaeology for that matter, and everything in between.
Right.
And so there's a lot of that capability that's being stretched, but there's a tendency to improve what's there by these young companies. Smaller, faster, cheaper, seems to be the focus with a lot of these young companies. And the other thing I would just say, to the other point about, you know, latency, and, you know, there's a real, you know, time issue, a real latency issue getting stuff down. I think what'll happen, and we have to think now in terms of the next 8 to 10 years, not being a very long time.
Right.
But having platforms in LEO, as an example, whether they're multiple stations or other platforms, and there's a lot of demand for these commercial stations that are being developed now, is having the decision making in orbit, and having the operator in orbit, so that for, let's say it's, you know, any kind of rendezvous, whether it's for debris or for orbit fab, and pulling up to refuel, the ability to have someone on a console in real time making a decision, I think becomes that next wave. AI in the meantime is obviously a major solution, but still, I think having human assets in orbit is going to happen, I believe, sooner than a lot of people are giving credit for, only because we've squeezed the both ends of this issue now with basic commercial flight, albeit short and low, to longer duration, and then the ability to have platforms where commercial companies, be they pharmaceutical companies, military customers, etc., want to have assets in orbit. I think we're going to skip to, once again, the brain being close to the eye, as Pierre said,
Right.
at decision-making.
Barbara?
Yeah, this has led to something that I've been thinking about and wanted to bring into this discussion. I'm really excited about AI and bringing, you know, the brain and the eye closer. I think it's fabulous. And still, as an architect, I'm looking at the difference between what we always called just engineering data. This is the truth. This is what's coming off the sensors, and what's being crunched and interpreted by AI. AI will have biases embedded in those algorithms that we need to understand. So I could see a significant body of work in just understanding what kind of biases we introduce into these algorithms, because we will. And how does that different from truth data? Engineering data is not efficient because it's bulky, but it's providing you all of the information. What's more efficient is the results of algorithms. But again, what biases does AI introduce, and do we understand them? Clearly, not totally. So again, I'm seeing a significant influence there, you know, because we are putting we're laying our interpretations into those algorithms. We can't help it.
Sure.
But yeah, understanding that is a factor, I think is important, even in specifying requirements. I'm good.
So,
thank you.
Thanks, Barbara. And so, Frederick, obviously this kind of plays into your sweet spot, right? Where we're talking about how do you get the brain closer to the eye? How do you everybody has their own professional biases. It's kind of how you solve problems. It's how you address things, and maybe interpolate and translate for your customer. But you start with your own, mental algorithm of how I'm going to solve this problem. And you bring together a team that maybe expands on that, amplifies it, and has its own uniques. But how do you, we've gone from requirements capture to some of the technology expansions and what are successes, what are the requirements for successes in the future? What are the requirements for success today? Because, we talk about nowcast. I mean, we're living here now, and if you're not viable commercially now, you better be commercially viable soon, or you won't be relevant in the future, right? So how do you wrap your head around that? Share your insights on that, please.
So the way I see this question is that I go back to this era. I don't know if you can see my phone, but I have a Samsung phone. And if I think that one of my apps have too much of a BIOS, I delete it and I install a new app. So we've had a small discussion in the chat window about cloud and edge. And what's interesting is that when we now, and the community as such, are enabling cloud storage and edge capabilities transparently in orbit, you don't need to be fixed on making a perfect algorithm from the beginning with its benefits and drawbacks. You can change your algorithms inside your satellite, or satellites for that matter, at any time. So you can start to see your satellite as just another server. If you buy a server on ground, you don't know today if you're going to run a WordPress instance on it, or if you're going to host a dating site, or if you're going to do banking on it, or if you're going to do everything if you have a big server. And it's the beauty of having not just edge capability, but edge, cloud, and storage capabilities in orbit, because you can start to treat your satellite as a data center, and you program it appropriately, and you can change the algorithms at any time. Just assume an old problem that Pablo is well familiar with. If you want to do an AI neural network to detect boats, for instance, that's very simple to do if you consider one case at one time, at one location, and in one particular month of the year. But if you want to trace aircraft or boats in winter, in spring, different altitudes, different oceans, etc., you will have a massive network. But you don't need to do it that way. If you have a cloud and edge capability in space, you can subdivide that particular problem into smaller ones, and you have one neural network for boats in winter, one in spring, you have another one for small boats, one for big boats, and you load the appropriate application for the purpose you have. Then you can train very optimized algorithms as well. So the key here is to start to see space as just another cloud center, and you tailor it to whatever it needs to do at any given time.
And so I think you've answered Sergio's question in your conversation, but just to be clear, the balance between cloud and edge then to you is maybe less discrete, because the cloud can be at the edge as you look at the flexibility with the functionality of reprogrammable platform.
Correct, and that's the same way on ground. If you have a high bandwidth, low latency link on ground, you can run real-time medical applications, for instance, remotely. But if you lose that link and you have a slow link, you cannot run real-time operations the same way. You have to fall back to some kind of autonomous operations with lower latency. The same thing you can deploy also in space. If you have a high bandwidth link, you can do real-time. If you don't have that link, you load a different application that behaves differently. So you can really optimize the missions or any configuration, just like you do on ground. We did a test not long back ago. We haven't flown this in space yet, but we did a test. Can we run, for instance, the ABB 800XA industrial control system in space? Yes, we were able to run that on our infrastructure off the bat, for instance, and that's used for Dow Chemical and for mining industry, etc. So the space, edge, and cloud capabilities in space unlocks everything that we have on ground the same way.
Okay, so before I turn over to questions from our audience more directly, I have one last kind of general question, and I'm going to ask each of you to spend just a couple of minutes, not too long, maybe 2 minutes each, to talk about commercialization and investment in the real-time Earth observation spectrum. There are a lot of Earth observation companies that are space-based. I mean, there's just a plethora, and so I think Pierre-Philippe, I think you'd said that each one, or no, I'm sorry, it was Dan said faster. One of you gentlemen said these new companies are faster, cheaper, smaller. You know, that's what they're getting at, right? They're taking something that's been around for a while and making improvements one way or another on either the sensor, the logistics, the build time, the tech refresh time. There's some angle, right? So really closing the business case for EO and real-time EO, I think has yet to be proven out in a broad way. We know that there's a government market. We know that there's a meteorological market, a science market, and so clearly there's an ag market in all the different applications. But what's necessary to make real-time Earth and commercialization of real-time Earth a profitable, viable, and long-lasting solution? So I'm going to start with Pierre-Philippe, and we're gonna work our way off to Texas. So Dan, you can plan on being last on this. But oh no, Barbara, you're in California. Well, we're still going to go Texas last. So we start with Europe and come back to the States. Okay.
Okay, thanks, Mike, for the honor to start on this one. I mean, if the answer was simple, I think a lot of people would be rich by now, and maybe we wouldn't have this session. But it comes to mind a comment I heard last week again at this Living Planet Symposium, that one issue with Europe is that they keep focusing on old market and try to improve it, as opposed to create totally new markets. And it could be that there is a totally new untapped market in this real time. We just don't know it because we didn't explore it yet. And the need might come when we start demonstrating how fast the information comes. And I believe in this because people need to make a decision quickly. I remember the whole financial industry just started to look at our products when we were able to count cars and count parking at the global scale with AI, because suddenly they had ability to do this consistently around the globe, etc. And that provided them with information which had financial value. I also noticed that with new technology, you could start new business models, and we're exploring this in particular in Italy with companies like Planetech and The Orbit, where we think that you could have an app space. I mean, Frederick mentioned an app, but an app is not expensive, but might have a high volume. So it's totally different from selling one service. You sell an app and then you sell it to many people. And this app can even be tailored for very specific application. Imagine a satellite going over the Earth. You have an app for forest, then an app for tropical forest, then an app for sea ice, then an app for geology, all running on the same orbit, suddenly creating more business as opposed to a single purpose satellite that we mentioned in the past. So I see a lot of opportunities here. I also wanted to come back to Barbara saying that, yes, I think we are all technology enthusiasts here, but there are big issues by running this AI, because at the end of the day, it's so easy to do correlation and to press on a button. You can always do things, but they might not mean a lot. And that's why we need really this domain expertise for interpretation. Frederick mentioned an example with tailored training on some specific spot, but I remember I had this discussion on crop detection, people training on crops, and they want to extend this, but maybe there are different crops somewhere else, so it's not representative at all. And all this issue comes in the training data set, so you get what you train on. So we need to be extremely cautious with AI. That's one of the message, but it opens very new avenue and possibly new business models.
Thank you very much. Pablo, your thoughts on that?
It's difficult to follow what Philip said. It's very interesting what he mentioned. I remember similar comments as well. It's true that there will be new markets. I remember in a panel, someone was mentioned about managing Earth, not only observing Earth, but managing as well. So performing activities, because we may have access to real-time data, performing activities that will help Earth, help managing the energy resources, managing the natural resources, etc. So I think yes, I think there will be a growing market in this area. We have discussed this at length as well with Dan in the past. He also mentioned similar ideas to us in the past. Maybe another area of commercial interest will be combination of satellite data with UAV data. Sorry, Dan, for stalling this. You mentioned this in the past, but this is a and this is an area of interest, I think. There will be investment, there will be commercial traction. We are seeing this in our own company. The fact that our software can perform the data processing so fast with such a low latency is becoming a big traction for many space companies and non-space companies. So I fully agree on this, on the trend of this market, the positive trend.
Thank you, Pablo. Frederick?
If I return to the phone analog, I would say that we don't know yet exactly what applications will be the killer applications, and neither did Apple when they launched the iPhone in 2007. But if we enable this key infrastructure, you can bet that there are some clever kids out there that will use this for ways that we have no idea today what they will use it for. What we've been able to demonstrate together with ESA is that it is possible to do this, and the hardware and software stack is there to enable it. And obviously we have some ideas of verticals that we would like to pursue where we see commercial value, but I think it's a hidden opportunity. It will reveal itself once we get access to the spacecraft. And as Pierre-Philippe knows, we have a program in Sweden called Space Edge, where we try to have a national edge lab for all different areas, including space, to stimulate app development. And this includes space, and good applications can be uploaded and orchestrated on spacecraft compatible satellites to stimulate the development of different apps. But we have no idea what kind of apps that will be developed. But we know that we can upload them and orchestrate them in orbit once they are developed and conformant.
So it sounds like app developers are going to have a bright future in space. Perhaps, Barbara, thoughts on that?
Yeah, absolutely. I totally agree and echo what the panelists have said thus far. I think, making significant volumes of data training sets available to individuals that are right now unknown, but will combine intelligently, combine different data sets. They're the ones that will figure out or have the insight into that combination and the value proposition. But right now, it's us bringing these vital capabilities to the table to make them available. Like the phone it was a platform that made innovation available. So I think we're setting up for a good future that way.
Thanks, Barbara. And Dan, I think this speaks to one of your sweet spots. And I see you've already answered one of the questions about the valley of death, if you will. So, and thanks for those of you who've answered some of the questions directly on the chat. I appreciate that, because I'm afraid we might not get to all of them. But Dan, going back to commercialization and future looking, what does it take? Your thoughts on that, please.
Well, the valley of death was something I had alluded to earlier, this challenge. And I think one of the problems that companies have, new companies, is they first don't understand whether or not there's a market for what they're building. So many young companies never ask the question, will someone actually buy this? And it seems a bit elementary, but it is a very real issue. And when you look at the investment side for commercialization and what the future holds, there's some basic rules that have to be followed, and some facts that have to be considered. There is not a lot of capability in the investment arena today to diligence space companies. The analysts, the investors, whether they're large, and mostly, of course, they're smaller VCs for the stage of the industry, there really is an expertise to say, here's how I tell a good technology from a bad one. Here's how I tell a good space company from a bad one. And there's leftover lessons and very bad memories of the mid to late 90s with .com and all these PowerPoint companies. I've got a great presentation. Look at what I can do. And they sold off that. They sold, if you will, the sizzle, because there was no steak at the time to sell. And so you have an industry that says, we don't want to go there again. We're dealing now with hardcore scientists, engineers, proven capabilities. It's a different environment now. But the investment community still doesn't know how to measure. So what do they look at? They look at, well, what are the experts now? So you look at the SBIR programs, the STTRs, or the government money has been granted around the world to help develop technology. That's being used as due diligence. Well, if the Air Force Research Lab, or the guys at Kirtland think this makes some sense, well, then maybe that's good enough for me. If NASA's awarding money because they see promise in a technology, well, that's good enough for me. But that still doesn't solve, it still doesn't solve the problem. The biggest issue is going to be the ability of any company to properly tell its story. So many companies don't know how to explain what they have. They really don't. It's not a build it and they will come marketplace. You need to identify a problem and show how your technology solves it. And the biggest thing that will separate everybody is differentiation. How is your technology better, more efficient, solving a problem than others? Because as you said, there are a lot of companies in EO. There are a lot of startups. Everyone has, and you'll find 3 or 4 or 5 that are doing pretty much the same thing. And they're racing to see who gets to market first. And it's just not it's not an efficient market yet. Those who have that category killer application that jumps over everybody else, they will attract the lion's share of the capital. And so you're going to see this, you're seeing this big bubble of companies with a lot of them in the same technology areas. It's like the launch market right now. There's 140 launchers. Okay, will we have 140 in 5 years? No. And this whole thing is going to start to consolidate a little bit, and the cream will rise. So I think for right now, it's a matter of making sure that there's a market and making sure that you can point to a problem that you're going to solve. With as simple as it all seems, most companies are not doing that.
So Dan, I think what I heard you say is that the future is bright and we should have optimism, but we have to be very serious about how we strive for the future and not be so Pollyannish about it that everybody's going to get a trophy at the end of the day, because that's not going to happen.
It's not going to happen. This is going to be, not so much ugly, but it'll be painful for a lot of companies, because they have great technology. And I've seen young companies that are 1 year, 3 years old that are dealing with everybody that they need to deal with coming out of the chute right at the beginning. And I see companies that are 5 to 10 years old that can't get anybody to listen to their story. Okay, so a lot of it is being smart about how you get your audience, how you bring your technology to the forefront.
Yeah,
and pay attention at the events, at all the conferences, but they are swamped with startups.
Right.
And this is, I think, we're trying to solve that problem, is how do you get the good technology in the hands of the people that need it? And a big part of that is, of course, the Defense Department has a massive pull appetite for getting this technology as well.
Well, it's interesting to me as an industry participant to see maybe a bimodal distribution, right, of industry participants. There's the very mature aerospace companies that have all of the wherewithal to bring to fruition new technology and implement change. And then there's this other end of the spectrum, which is, you know, the quote unquote new space entrants, a little more nimble, less capitalized, but also different in a different risk spectrum. And then when you bring them together, there's a lot of power, right? That's where I think the interesting evolution will become. How readily can these new technologies be adapted? I'm going to go to one of the attendees' questions. Pierre Wilhelm says, thanks very much to the panelists for interesting discussion. We talked a lot about onboard processing and a bit less about carrier for the information to get down to the user, which, by the way, I'm keenly aware of being an Atlas ground network provider. We like to say that like our competitors, we have antenna and they have antenna, but just like you have ears and I have ears, it's the stuff between them that makes the difference. And we are a software dominated company. We were Inc. 500's 15th fastest growing software company in 2020. And so we believe that the innovation in the infrastructure has to do with the orchestration software to simplify and rapidly integrate spacecraft into a network. It's not about a more robust network in physicality, but a more robust network in its architecture, so you can leverage the strengths of multiple assets, multiple apertures, and a family of capabilities as opposed to one dedicated system. That's how we think about it. But the question wasn't to me. The question's to the panelists. So, you know, I'll start with Pierre-Philippe. What are your thoughts on infrastructures and architectures to support a real-time EO data transmission to the user?
Okay, but that's the backbone, so it's a must. And we are building a lot of infrastructure for launches, for ground segment, etc. And as you mentioned, the aspects of agility of this is increasingly becoming important. And I noticed that software is taking over. Someone said software is eating hardware in a different domain. So you can be more, let's say, agile, fast with software. Just to give an example, we had a session on super resolution during the workshop we did last week. And there is a lot of technology push in this, because people want to have higher resolution from sensor who have a certain resolution. So how can you do that? And it happens that software can actually capture information below the resolution by using time information, other data, so they learn on high res and then you transfer the learning to medium res, or you use multiple angles. So there is some magic in there that you can extract a feature from this. But the whole session show, first you need to understand why you do that. And that comes back to what Dan was saying about solving a problem. Why do you need to have higher resolution? And it happened at the end of the day that many of the users, they just needed some feature, and you could train the software for this feature. So it's not actually bringing the whole image at a certain resolution, it's capturing information that is more relevant. And that's how I think the evolution of infrastructure should go. It's really capturing this value by being agile, being tailored to user needs, etc. So there is a big need there to have this traditional school of infrastructure to come with the new school of technologists and the user in the middle to actually shake this and find ways to make this infrastructure actionable and to bring over the last mile. And this is happening with onboard processing. We mentioned real time at the beginning of this discussion. If you are a farmer in Africa and you have a mobile phone, you don't need the whole data, you need an SMS of a few kilobits, just telling you the actionable information. And that's where the intelligence comes in. I mean, the human intelligence, not the artificial one. Okay, I hope I addressed the question, because
yeah,
it was
I think so. I'm going to ask one more person to address that, and then we'll go to one last question from from the audience, if you will. Pablo, your thoughts on the infrastructure, the dissemination piece?
Yeah, I tend to agree with what it has been said. Software will be a key element. I mean, there are so many satellites in orbit performing Earth observation or the like, that having a software able to be deployed in those will be very important, will be a critical element in all of this. And consider we have been working quite hard on this, being able to minimize our software so that it can be uploaded to any satellite and to be able to run in very tiny computers as well. Yeah, because the cameras are there in space, the infrastructure is part of the infrastructure is already there. So one of the key elements in this whole new setup will be able to run advanced software in this kind of solutions, no? This kind of existing spacecrafts. This is my feeling about this.
Thank you. I've got one more question. I'm reading the chats right now, and again, thank you, panelists, for responding directly as well, because I don't want these questions to go unanswered. There's one question from Sylvan that I thought was really a unique perspective, and I'll throw this out to Barbara and Frederick to share a view, and then we've got to wrap up, unfortunately. It says one could say that real-time observation implies human intervention and decision-making, and on real-time on-edge processing, AI is the next step, with humans only being informed, so that satellites' Earth data processing time becomes less important. It's almost as if real-time data processing is to inform the platform itself, and humans become the bystander. Yes, the beneficiary of the information, but humans way out of the loop, and this is what I'm taking. And so I'll go to Frederick for a response, and then I'll go to Barbara for a final, and then we'll do a quick wrap up, okay?
So I think the simple answer is yes. And the reason being is that we are going this way in the terrestrial edge, and we will see the same also in space. Systems will become more and more autonomous, and there will be more and more of reasoning going on in the systems. And you would ask the system, I have an interest in these data points, or I have an interest in this information, and the systems will more and more autonomously give you that data, whether it requires fusioning of 3 different sensors on 3 different satellites. It really doesn't matter to you as an operator or you as a consumer, as long as I get my information. And this is a very clear trend also on ground, especially in Internet of Things, and we're seeing the same thing in space as well. And we just last year delivered 25 units to NASA Ames to establish their distributed spacecraft autonomy cluster, where they are going to simulate a lot of these aspects going forward.
Barbara?
Yeah, echoing what Frederick said, we will undoubtedly move from the highly enabled position of being able to get near real-time telemetry to other regimes, and we will, of necessity, pay attention to and evaluate how our AI algorithms are responding in relation to truth models. We have to go in that direction. It's imperative for beyond near Earth missions to do that. And I think that in itself, to take on AI verification against truth models is an excellent business opportunity. Right. And I think worthy of certainly government investment and commercial. The ability to trust machines is where we're going with this. We're taking the best that we can do to develop the algorithms, and then certain aspects will take over in our absence. So I think it requires that we bring people of different disciplines even to the review of algorithms, to look for biases where perhaps a traditionally trained AI engineer who's doing that development would not necessarily notice those biases. It's an exciting field, and it's where we have to go to be able to conduct out of contact space missions in the future.
So interesting to me. We only have 5 minutes left here as a panel, and my mind has been expanded just in the last 90 minutes in a way that I didn't expect. And the biases and algorithmic biases was something that those words would never been put together in my head because I don't do that for a living. But I can see where that can be a problem. And if you're in just one train of thought, you're in one train of solution. And when you think about cislunar or Martian activities or asteroid activities, where the distances become challenging for latency and decision making has to maybe be done faster than the link provides. How do you do real time Earth to real time Moon, right? To real time Mars, and do our algorithms then, does the AI become the articulator of the new requirement before we're even aware of it cognitively as a human? I don't know. That's kind of where I ended up with my cup of coffee today. And real time Earth observation is so contextual. It is so mission dependent that I think it's almost silly to state real time means. But I also know as humans we have to have context with which to build around. And so the 3 minute makes sense to me because that's pretty damn quick. Is kind of what I think that is. It's fast enough to make some decisions, but not all decisions. Like I'm not going to drive a car with autonomously with a 3 minute delay. I'll miss my exit. So I think that what I'd like to do at this point is just maybe give each of you roughly 1 minute or 30 seconds to just kind of give a wrap up of your thoughts on real-time Earth observation for the near future, for the near real-time future, if you will. Frederick.
I'm having reception problems here. We have lightning strikes going on here, so I missed the last part there.
30 seconds on real-time Earth observation.
So I think that we have demonstrated the capability in orbit already, and we are going to see more and more and more of it. So I think we are down to the fact now that it's like any other edge industry as on ground. So we really have to change the mentality and think that it is possible. We can deploy new applications very quickly. And with that, you can change the entire way we do ConOps and the way we build satellites and launch them. You can now launch satellites also on speculation and fill them with contents afterwards.
Thank you, Dan.
As I think about this, number one, thank you for the opportunity. It's been a pleasure with all of you on this panel and with our audience. I think I'm going to go back to just the issue of solve the speed, solve the latency issue, and the marketplace will develop multiple applications for it. But you have to solve the utility itself being able to operate at the right level before the applications come in. It's not going to come the other way around. There's a lot of people dreaming of what they could do if they had that capability for real time, but I think that solving the real time issue is going to drag a lot of new applications out.
Got it. Barbara.
It's about architecture, fitting solutions using multiple capabilities. I think software is the glue, and I really like the whole containerized solution, but also interconnected container capabilities as well. Architecture will, I believe, solve the speed problem and then empower the development of the market.
Thank you. Pierre-Philippe.
Okay, so first of all, thank you very much again for inviting me, and it was really a privilege and a lot of fun. I think you summarized it already, Mike, by saying that you expanded your view during this panel, because what I think we are talking about is tools, edge computing, AI, that really expand our view, and there comes the opportunity for science, but also application. And my plea here is really that we need human intelligence, so we need people to work on these topics. They don't need to go to do marketing, etc. with AI. There is much more interesting topics to address. So please reach out to me. At least I have some opportunities for research fellows. But really, I would love the community to move on this kind of topics, to try to do distillation for edge computing and to develop the cool apps that Frederick was mentioning that smart kids would do, and we don't see it coming yet.
Great. And Pablo, the orchestrator of this event, and I'm sorry we're running a bit late, but you do get the final word, sir. Muted. You're muted, Pablo.
You're muted.
Sorry about that. Sorry about that. I was giving a massive speech and I was muted. No, I wanted to thank Mike for hosting this. It has been a great pleasure to have Mike as a moderator again, and obviously a big honor to have all the panelists here. My last view, yes, I tend to agree. The keys are software and architecture, particularly AI and real time. I think these will be the absolute future of Earth observation. I am on that area, and I hope our company will be part of the enabling solutions for this.
Thank you all for your time today. Thanks, audience, for joining us and your engagement in the chat. I invite you to also feel free to reach out to our panelists after this call. We are a relatively small community, but we still don't know each other entirely all yet, and there's still so much more to learn. I've learned a lot today. I hope that we've each expanded each other's view at least in some small way. And hats off to Clepsydra and Pablo, and wish you the best of luck in solving data processing problems, making data faster, cheaper, and safer for all. All right, thank you very much. I will say good afternoon, good morning to each of you, and sign off.
Thank you, everyone.
Thanks, everyone. Have a great
Bye-bye.
Bye.